Ossification is defined as formation of bone, and intramembranous ossification starts typically around the 9th week of pregnancy. This method creates flat bones of the skull, the mandible, and the clavicle. It occurs within the membrane of fibrous connective tissue. The process of intramembranous ossification begins with the transformation of mesenchymal cells. Mesenchymal cells are stromal cells that can change into a variety of cell types, such as osteoblasts, chondrocytes, or adipocytes. For intramembranous ossification, the mesenchymal cells develop into osteoblasts. They release organic matrix material and then become mineralized through crystallization of calcium salts. Alkaline phosphatase is an enzyme that helps trigger this activity. After all this, the mesenchymal cells are turned into osteoblasts. Matrices, known as spicules, start to form around the osteoblasts and interlink with each other, resulting in the development of osteocytes. Osteocytes then group together as they continue to form to create osteons, which is the basic building block of compact bone, which we'll get to later. Alright, intramembranous ossification all begins in the ossification centers. As osteoblasts continue to develop, they need a supply of oxygen and other nutrients, so blood vessels begin to penetrate the bone and distribute nutrients and all the supplies they need. First, there are three major sets of blood vessels: the nutrient artery and vein, the metaphyseal vessels, and the periosteal vessels. The nutrient artery vein are what supply the diaphysis form. These vessels enter the bone during its endochondral ossification phase via passageways called nutrient foramen in the diaphysis. Metaphyseal vessels are what distribute blood to the diaphysis surface of each epiphyseal cartilage, where their cartilage is replaced by bone. Periosteal vessels are the vessels from the periosteum shaft that provide a blood vessel supply to the superficial osteon layer of the bone. These vessels may also enter the epiphysis, where the secondary ossification centers may receive blood distribution. Some blood vessels will be trapped inside the bone as the spicules continue to interlink. In the first stages of intramembranous ossification, the bone is only made of spongy bone. Spongy bones are located in areas of the body that are less stressed. The bone matrix makeup of spongy bone is made up of trabeculae rather than osteons. Spongy bones may contain yellow bone marrow or red bone marrow, where red bone marrow is responsible for blood cell formation and yellow bone marrow is responsible for reserving energy. Later, in intramembranous ossification, bones may develop into compact bones. Compact bones are made up of osteons, and blood vessels run through these osteons, supplying blood deep into the bone and to the tissues of the medullary cavity. Compact bones are located in areas of the body that receive the most stress because the osteons is uniform and make compact bone very strong. The bone matrix compounds are also always being recycled and restored by the process of remodeling. This process is where older organic and mineral components from the bone matrix are removed by osteoclasts through osteolysis. Usually there's a balance between the making and removing of osteons. As osteoblasts create osteons, an osteoclast removes one. Spongy bone can develop into compact bone through remodeling, where spongy bone can be removed, creating a medullary cavity, and then can form compact bone. Remodeling of bones continue throughout one's entire life. That about sums up intramembranous ossification. Thank you for watching.